Good afternoon, everybody. You're welcome to my channel. Uh, we're here to talk about the volumetric analysis of WAEC for 2003, which is between hydrochloric acid and hydrated sodium carbonate. Let's look at this question that will guide us and prepare us for what is to come. Question number 1 says that here is 0.10 mole per dm cube of HCl, which is hydrochloric acid. B is a solution containing 5.0 gram per dm cube of sodium carbonate. We're to put Hale inside burette and titrate against hydrated sodium carbonate using a pipette of 25 cm cube and using methyl orange. And from the question being asked here, we're to calculate the average volume of acid used, the concentration of anhydrous sodium carbonate in mole per dm cube, the concentration of anhydrous sodium carbonate in gram per dm cube, and the value of X. And again, we're to find the percentage of water of crystallization in solution B. So those are the things we're to do. So the little information here is we record the volume of our pipette to be 25 centimeter cube, and the indicators used as methyl orange, and you draw your table will have been drawn there. You have to fill up the table with your answer from the burette. So our final answer for the titration 1 is 9.10, the second titration 8.90, and the third titration is 9.90. So when you add the three together and you divide by 3, your final answer will give you 9.00 cm3. That's the average volume of acid use. Always remember to put unit. If you don't put unit, your final answer is 0. So let's look at the question number 1. The question number 1 states that we should find the concentration of anhydrous sodium carbonate in mole per dm cube. That's without the water crystallization. So you use the general formula CAVA is equal to CBVB is equal to NaNB. Remember, our NaNB is from our equation number of mole of acid all over number of mole of base. When you make CB the subject of the formula, you have CAVA multiplied by NB all over VB multiplied by NA. Our CA is equal to 0.10 mole per dm cube. That's from the question. And our volume of acid, that's the average volume of acid used, as 9.0 centimeter cube. And we also have the volume of the base VB, that's 25, and also the number of mole of acid that we from the equation, which is 2. So when you calculate the whole thing, you have your concentration of base as to be equal to 0.018 mole per dm cube. That's for number 1. So let's look at number 2. When you look at the question number 2 that says we should calculate for the concentration of sodium carbonate again in gram per dm cube, that is the mass concentration. So to calculate sodium carbonate in gram per dm cube, which is the mass concentration, you use the second formula, which is molar concentration in mole per dm cube, that's C, equal to mass concentration divided by molar mass, which is in gram per mole. So the first thing is to calculate the molar mass of anhydrous sodium carbonate, which is the sodium there 23 multiplied by 2 plus the carbon, which is 12, plus the oxygen, which is 16 multiplied by 3. So when you add everything, you will get 106 gram per mole. So when you cross multiply, the mass concentration will be equal to molar concentration in mole per dm cube multiplied by your molar mass, which is 106 gram per mole. So when you calculate the whole thing, you have your 1.91 gram per dm cube. So the third question is we should find the value of X. There is 2 different ways in which the value of X can be determined. So the first method is here, and also the second method is at the right hand corner there. So let's look at the first method. The first method is you have your mass of anhydrous salt all over mass of hydrated salt, which will be equal to mass of anhydrous salt, molar mass of anhydrous salt all over molar mass of hydrated salt multiplied by 100. So let's go to, when you fill it up, the mass of anhydrous salt, that is the molar mass concentration in gram per dm cube, that is 1.91 all over 5.0 gram. 5.0 gram is from the question, that is the mass of hydrated salt, which is equal to the 106 molar mass of anhydrous salt, and all over molar mass of hydrated, you see Na2CO3 is 106 plus 18x, that is that x we are looking for, which is attached to the molecules of water. So when you do the little mathematics there, you cross multiply, you have 106 plus 18x is equal to 277. So 18x will be equal to 277 minus 106, and after that you have your divide by 18, you have your 9.5 and approximate to 10. Let's look at the second method. The second method here is to find the value of x, which is a little bit different from the first method. The second method is first you can calculate the molar mass of hydrated salt. When you now calculate the molar mass of hydrated salt and equal it to that compound, you can find the value of x. So the value here, will calculate the molar mass of hydrated salt. Here, to calculate the molar mass of hydrated salt, we have to make molar mass the subject of the formula, you have, that's mass concentration in gram per dm cube all over molar concentration. Mass concentration is 5.0, which is over, that's the concentration you've gotten, that 0.018 mole per dm cube. So after that you have 288 gram per mole, that's the molar mass. So after that you equate it to the compound, and you find the Na2CO3 is 106 plus that 18x is equal to 288. So after that you make x the subject of the formula, that's 182 divided by 18, and you have your x. You can say this is the same as the first one, so either one you understand better out of the two, you can use it, which is definitely correct. So let's look at the third question, that we should calculate the percentage of water of crystallization from solution B. To calculate the percentage of water of crystallization, you have which is equal to mass of hydrated minus mass of anhydrous divided by mass of hydrated multiplied by 100. Mass of hydrated in the question is 5.0 minus mass of anhydrous, which is 1.91 all over 5 multiplied by 100. So you divide the whole thing and multiply by 100, you have your 61.8%. Thank you very much for listening, and you can also check again for the qualitative analysis and other question of volumetric analysis. Thank you very much.